Hello, chemistry students. This is Mr. Pham, and this is today's lesson for April 3rd, 2020. It's Friday, but really it's Friday for me because I'm recording this right now on Friday. So, the last four lessons, we have covered waves, how they are a disturbance that moves through a medium, and that they have certain characteristics, and that there are different numbers of waves, and they have different wavelengths, and the fact that the wavelength is related to the number of waves. Remember that if there is a larger wavelength, you're going to have fewer waves. Well, one of the characteristics that I've mentioned in several of the videos is something called amplitude. You've probably heard the term being amped up, or I even think there are drinks that are called amp. I don't know what brand it is, but when you hear that term or phrase amped up, that typically means that something is more intense. You may have heard of these things called amps that you put in your cars. And for those that have ever messed with speakers in their cars, know that if you want a big booming sound, well, you can't just put a big speaker in your car. You need something to push more energy into the speaker so it can be louder. Well, the machine or the part that they're using is called the amp, under the term amplifier. There's the term to amplify in general, which means to increase somehow. And all of this relates to this next property that I'm going to cover, amplitude. Whoop, no, this is the wrong one. Let's go back. There we go, right there. And that's not it, that's wavelength. There we go, amplitude. The amplitude is the distance from zero, which is this right here. It's that center line. That's the medium, not moving up or down, but the amplitude is the distance from zero to the highest point or from zero to the lowest point. That is called the amplitude. So you typically measure it from zero to the top of the crest or from zero to the bottom of the crest. Now, in most situations, when you draw waves, you're going to draw them where the amplitude of the crest is exactly the same as the amplitude of the trough. In real life, that doesn't actually happen. The amplitude will increase or decrease, or it will typically decrease the further away the wave is from the source that created that wave. But we're going to, in our drawings, we're going to make sure that the amplitude is the same for the crest and the trough throughout the duration of the wave. And then later on, we'll talk about how that changes. But when it comes to the effect that amplitude has, I don't know what happened to that. There it goes. On our waves, well, since we're looking at sound, let's just look at what happens when you change the amplitude. Sorry, we're just looking at light. So let's see what happens when we change the amplitude of light. Uh, Amplitude affects the brightness of the light. Now, that brightness has nothing to do with the type of light it is. To make things easier for you, let's talk about just visible light for the moment. The light that you see, the light that you can see in this video, the light that's coming from the sun, the light that's being reflected off of everything around you, allowing you to see that thing. Amplitude affects how bright that is. So think of a situation where you're inside, you got all these walls, and you got this sunlight coming in. Well, you can see the things around you. But the moment you go outside, all of a sudden you have more light that's available. Well, what you have done is you have increased the intensity of the amount of light that you're seeing. Now, all of a sudden, things are brighter. That's because there is a greater amplitude out there versus what you're seeing inside. You have less light to begin with inside, but also the light that comes through into your house is going through a window, and that window is going to take away some of the energy or some of the amplitude of the light that's going through, and so now it appears to be dimmer. So when we talk about amplitude and intensity, we use terms like brightness and dimness, and definitely amplitude affects that. If you want to draw a parallel to sound, amplitude would be what then? What would it increase or decrease? Well, the answer is already on the screen that you can see. It increases the volume. So right now, I'm speaking with a certain intensity, with a certain amplitude. But if I was to raise my voice all of a sudden, then you would hear an increase in volume. That's because I have a greater amplitude to the sound waves that I'm producing. And that deals with energy, which we'll talk about later. So amplitude does not, as review, does not affect the type of light, whether it's red, green, blue, ultraviolet, or gamma rays or radio waves, which are all types of light again. It simply affects how intense that light is, not type. So I am going to pause my recording. And now what you should see is my wife just yelled poop in the background. Thanks, babe. You're on video now. So now I'm going to kick over to this animation where you can see the wave on a string again. Right now I have, I don't know how many waves that is, maybe 4 waves being represented. If I slow it down or pause it, I can see 1, 2, 3. It's about 3.5 waves right now. But if I put this in slow motion, you can see how from here to the highest point, I guess the highest point would be right there, that's the amplitude. It is the distance from 0 to the highest point, or 0 to the lowest point. Now this animation is not keeping the amplitude consistent because there is going to be a loss of energy, which means a loss of amplitude. We're going to cover that later. Right now I just want you to be able to see the point from 0, which is right there, to the highest point, 0 to the lowest point. And if I continue the animation, but if I reduce the amplitude, you will see an immediate effect on the characteristics of the wave. Can't do a 0. Let's do a normal speed. So now all of a sudden, I have waves that look smaller. That is a decreased amplitude. So let's kick it over to my Show Me app, and we're going to represent amplitude on our wave diagram. So first I have to, let's go forward. Let me draw my wave diagram. Remember that this is 0. We're going to draw some lines. 1, 2, 3. And then we're going to go below the line. Oop, that's a 1. Let's fix that. Ooh, that's ugly. Go. -1, -2, -3. Drawing with your finger, not easy. So remember that waves travel through a medium again, and that medium for a transverse wave goes up and goes down. Now, I'm going to represent something with an amplitude of 1. So on your future assignments, I'm going to tell you what the amplitude is, and then you have to draw the wave. So my amplitude, there's no fancy symbol for this. We just call it amplitude. Amplitude is going to be 1. Now remember, when you draw a wave, it should have an up and a down. It should have a crest and a trough. When I draw the wave, I need to make sure that I only go at my highest point up to 1, which is right here. And my lowest point can only be -1, because what goes up must come down, but it must go below 0 as well. Now, my lines aren't drawn perfectly. That's fine. I'm using my finger after all. When I draw the wave, I'm going to go up and only at the highest point go to 1, but then I'm going to come down and a -1. And so that represents an amplitude of 1, not just 1 up, but also 1 down from 0, because my wave makes the medium go up or down. Now that's just one wave with an amplitude of 1. If I want to draw 2 waves with an amplitude of 1, then I would just repeat this process. I find it easiest to draw some kind of line or some kind of mark that allows me to go to a highest point versus lowest point. If that means you need to do something like this to give you some kind of guide, highest point versus lowest point, then so be it. See, not perfect, I know, it's ugly, but still something to help you along. So let's do this again. Now let's have an amplitude of 2. That's 2, that's 1. This is 0 again, minus 1, minus 2. So if I want to have an amplitude of 2 to make this better, because I know what you draw is gonna suck. It's gonna be bad. Let's go ahead and just draw some kind of guide. Dotted line. Ooh, look at those pretty dots. Sarah, do you like those dots?
Yeah.
It's kind of fun, isn't it? All right, so now I'm going to draw a wave, one wave with an amplitude of 2. There you go. One wave with an amplitude of 2. Now there's 2 waves with an amplitude of 2. It's not going to look perfect. It's fine. If you happen to get the paper, you'll even be able to print this paper off when I post it on Google Classroom, but it will give you something easier to draw on. One of the common things students will do when they're drawing it on paper is to use some kind of straight edge. So put the straight edge and it goes right there, and then you have your highest point. Then do the same thing with your straight edge for the lowest point. And there you go. That gives you something to draw on, and that's amplitude. So your assignment is going to be to draw different numbers of waves with different amplitudes. I know it's not going to be perfect. That's fine. We can do things a little differently here. If you want to go to Google Drawings and then draw with your mouse what you see here, the wave diagram. Once again, a wave diagram is simply some kind of y-axis, some kind of x-axis that represents 0, and then you put the little tick marks there. But you can use a Google Drawing. I can put a Google Drawing template on my webpage that will assist you, but that's going to be your next assignment, to draw waves with different amplitudes. You're going to be drawing different numbers of waves and then drawing waves with different amplitudes. And that is it. That's Friday. That is the last lesson for this week and the last assignment. A couple of things that you need to keep in mind. One, you are required to watch these videos. I'm assuming that if you're watching this video, you're hearing this message, so you know you're supposed to watch these videos. If you know of any of your friends that are not watching these videos, please tell them that they are supposed to be, and that there's an assignment at the end of every day. I know one of the questions I've had most recently is, what do I do with all these assignments? You can turn them in to the office whenever you want to, but my suggestion would be to hold on to all of these assignments until we get back. Don't fall into the trap of not doing these until the very end, because we might be back April 17th, or we might not be back at all, but you still are required to do these assignments because each assignment is your attendance for that day. I hope that you're learning something from these lessons. Uh, Definitely, we're going to go into why talking about waves is important. Things like telecommunications, pretty big deal, because you're probably watching this video right now through the internet, which uses some type of signal. So we're going to be talking about that later on. We're still going to focus, though, on some characteristics. The next video that I'm going to publish is going to be about frequency. So until then, I hope you have a good weekend whenever you're watching this video, and I will talk to you later. All right, see you later.